Hi, and welcome back to our chapter 2 of Microeconomics. Consumers in the marketplace, now responsiveness of demand, or elasticity. Elasticity, a concept that we know basically from everyday life, and we know that things are more or less elastic. I have a piece of string here, and when I pull this piece of string, there's hardly anything happening because it's inelastic. Whereas if I take a rubber band, we all know that we can stretch it, and there's quite a high elasticity. And that's at the end what we talk about when we talk about demand and the responsiveness of demand. So elasticity is the concept. The question that we in fact ask here is the following. How strongly do consumers react to a change of price? How strongly do we react to a change of price? If we usually buy something, let's stick to our apples, and now the apples become less expensive because it's the season or whatever, do we buy more, and if so, how much more? More concretely, the question is this one: what is the relative change of quantity demanded in respect or as a consequence of the relative change in price? So we have the, again, dependent variable, the quantity demanded, how much do we demand? And you might realize that we have this term here, relative change in quantity demanded in respect to a relative change in price. This relative is something we have to analyze, we have to find out in order to understand the concept of elasticity. Let's look into our presentation, or the book presentation. Here you can also see the different ideas. On the left-hand side, you have a demand that we call elastic. Even if the change in price is relatively small, then we observe a large change in quantity. That's like our rubber band. Before you bought 2 apples a week, and now the apples are 10 cents less, and you buy 5 apples a week or whatever. There's a lot happening. On the right-hand side, there's hardly anything happening. Although the price of apples went down from $2.99 to $1.30, people buy just a bit more. Perhaps the shop just sells 3% more apples. That's like this string. There is hardly anything happening. A bit, if I try to put it apart, but not a lot. So left-hand side, elastic demand. Right-hand side, inelastic demand. In order to understand how to measure elasticity and what we can do with this concept, let's go back to the example, the demand curve that we have been using in the last video. In our example, we already looked at a price change that we can see here, the price going down from 3 to 2, and as a consequence, the quantity demanded going up from 40 to 60. And let's analyze this a bit closer. What is the relative change? The absolute change of the price is what we call delta P minus 1. But what is the relative change? Relative means this change, this minus 1, in relation to the price that it was before. So it went down from 3 to 2. Relative change, 1 out of 3, or 33%. The relative change would be delta P over P, so minus 1 over 3, and that's 33%. In fact, negative 33% minus 33%. The same concept with the quantity. We have a change from 40 to 60, so that's an absolute change, delta Q, of 20. The relative change, again, is if I refer the 20 to the 40 that we had before. So again, delta Q over Q, 20 over 40. And that's 1/2, that's 50%. And here we now have the two relative changes. We have minus 33% in price, but plus 50% in quantity demanded. Our book and presentation defines this as formula 2.1, the elasticity that is typically abbreviated by an epsilon, a Greek letter E that we see here. Sometimes also an eta is used, but here in this book we stick to the epsilon, which sort of has the advantage that it looks quite like an E for elasticity. Percentage change in quantity demanded divided by percentage change in price. Using the symbols that we used in the graph before, that means that epsilon is delta Q over Q divided by delta P over P. Both measured in percent, so we compare two percentage changes. That's a nice formula, or perhaps not so nice, as you have this double fraction and always must compute this. That's why we often transform that formula into the other one, this 2 that you already saw on the slide, by saying, okay, we recall from school maths that we divide two fractions by multiplying with the inverse of that fraction. So I can transform this into delta Q over Q times P over delta P, which is kind of another formula, but the question might be, so what? In fact, this formula doesn't help a lot, but it's easy to, again, transform it as it's just two fractions multiplied. So I can also resort the parts of the fraction. I can as well write delta Q over delta P times P over Q. Now this one is in fact more helpful than the middle one because it contains an element that we already know from our demand function. Have a look whilst we highlight our two formula here. Having rearranged the formula with the respective numbers 2.1 and 2.2 from our presentation from our book, some of you might have noticed what we said earlier. Yes, there is one part of this equation that we already know, and in fact it's the left part, delta Q over delta P, which if we look at the left-hand side to the frame before, we identify as the slope of the line. Delta Q over delta P is the slope, is our B. Both formula have advantages and disadvantages. The left-hand side was the one with which we defined elasticity, and in fact that's what we can use it for. It's the relative change in quantity over the relative change in price, with the disadvantage that the formula is a bit more complicated. The right-hand side has the advantage that it's easier to do. If we replace the delta Q over delta P with B, it just says B the slope times P over Q, the P and the Q value before the change. So it might be easier to compute this. We are going to use both of them, as both of them tell a certain story. To conclude this initial definition of elasticity, a last view to our slides, we see here the range where elasticity can fall, and it can take any value. It can be between minus infinity and plus infinity. But in fact, what we are going to do in the next step when we talk about the price strategy, we are going to take the absolute value. You can see here the absolute bars around the epsilon. And if we do this, then there is no negative sign, and the elasticity can be 0 or bigger. It can be 0, includes both. It's between 0 and plus infinity. And we're going to use this in the next step when we say, how can we use this in order to talk about prices? Our book, let us copy this over. In the book, you find several more aspects, two aspects. One is what at the end determines elasticity. What brings us to reacting in either a relatively strong way or hardly reacting at all, or something in between. That might be the availability. Are there substitutes? Sticking to our example of apples, the availability, the number of substitutes, can be other fruit. So if the price of apples increases, it's €1 more expensive than yesterday, but the prices of bananas or pears or whatever didn't change, then we might react in a relatively strong way and say, okay, today I don't buy any apples, but I buy pears. And the reaction would be very elastic. On the other hand, if we just have the small 24-hour shop and we need some fruit and they only have apples and these apples are more expensive, we might not react at all to the price change, but we pay what is demanded, and that would be an inelastic. It has to do with preferences, how badly do we want these goods, the time, the definition of the market, whether we look at a relatively small market and say, what is my reaction, what is my responsiveness to demand in this 24-hour shop at 4 o'clock in the morning, there's nothing else, or is it 10 o'clock in the morning and we can go to the farmer's market, to smaller shops, to a big supermarket, and we have a lot of alternatives. That's what defines our elasticity, or what determines our elasticity. The next step, in fact, here this slide in red, so it marks this is something, this slide you should keep in mind. Here we have the definition again, I don't have to repeat. And the next steps we are going to discuss two things. Number one, the value of the elasticity, whether it's bigger or smaller than 1. And keep in mind here we look again at the absolute values, so no negative sign. And from this we are going to derive the price strategy. Later on, the next step will be to look at the sign and then determine the types of goods. Our table 2.1 in the book differentiates between different concepts or different descriptions here. Inelastic demand and elastic demand, we talked about these two, and then obviously in between there is the point where it changes from inelastic to elastic. We call this unit elasticity. Inelastic demand, if epsilon without sign, so epsilon, the absolute value, is smaller than 1, is inelastic. If it's bigger than 1, it's elastic demand. In between, unit elastic. And we have the two extremes, an elasticity of 0 we call perfectly elastic, and an elasticity of infinity, an infinite elasticity, which is more like a theoretical concept, would be perfectly elastic. And let's go back to our example, to our equation and demand curve, to understand, number one, which are the elastic and inelastic parts of the demand curve. And number two, how can we use it in order to define a price strategy? In order to understand how this works, we start a new frame. You can see here to the right, now we have frame 2, value of epsilon, and from there to be derived the price strategy. You can see that we have the similar graph to what we have been looking at before. You will see there's one slight difference, but that also changes our demand function. And you can see here that we are going to talk about the value of the elasticity at different points of the demand function. And especially we start with price changes and ask ourselves, okay, what is the elasticity at different points? And we will see that up here, in the middle, down there, whatever, we are going to find different values of the elasticity, and we're going to learn, okay, what does that mean? What can we do with this? I'd like to invite you to not only listen to this video, but stop the video from time to time and then say, okay, I try to find the answer that Peter then give me in a second, but it's far better if you try on your own and not just wait until I say, okay, the number is this. But that's up to you. You are just invited. When you look here, three situations. Situation 1, the initial price is 40 and the price changes to 39. Second situation, initial price 25, price goes down to 24. And third situation, for initial price 20, price goes down to 19. We can also observe that in all cases, there is a price change of -1. The price goes down by 1. Now the first question is, what is the resulting quantity, or what are the resulting quantities at the different situations? So let's see, if the price is 40, what is the quantity 1? In order to find out, we could either take a ruler and try to measure this in the graph, which would be a bit complicated. It's easier to write down the function of the equation. So writing down, let's say up here, quantity demanded equals A plus B times P. So we have to say, okay, what is A, what is B? That's the first situation where I ask you to pause the video, think about it. What do you think are the values of A and B? So you would write down quantity demanded is first number minus second number times P, and then check whether that's correct or not. And we're back. So I continue now. If you want to think more about it, you have to pause your video. Quantity demanded is, it starts at our point A, which is 100. And so we could say it still starts at our point A, which is 100. It's still negative as it's a normal demand function that has a negative sign. But you might have realized that we changed a bit here, or not only a bit, we increased the prices. This time now it's not the maximum price of 5, but it's 50. So the demand starts at 100, and at a price of 50, the demand is 0. If we think about it, we come at the end to a B, a slope of -2. So we have 100 minus 2p. This is our new demand function here. Now, once we have the equation, we can compute each and every quantity depending on the price. So we can say the price is 45. What is the quantity demanded? For a price of 45, quantity demanded would be 100 minus 2 times 45. And that gives us a quantity demanded of 10, as we have 100 minus 2 times 45, 100 minus 90. That's just the example. And now your first task is to compute the different quantities down here for the 6 different prices that we have. And then we observe how does the quantity change and what do we learn about the elasticity. Second step will be to compute the elasticity. So again, pause the video here in order to be able to say, okay, I did it on my own, and then check whether I put down the same numbers or not. So I hope you have 6 numbers down here following the same pattern as we did up here. We put the values for price in there and then check what is the quantity demanded. And doing so, we come to, if the price is 40, then the quantity demanded is 100 minus 2 times 40, 100 minus 80 gives me 20. Whereas when the price goes down to 39, then our quantity demanded is 100 minus 2 times 39, 100 minus 78 gives us a quantity demanded of 22. And we also might say, okay, we were already able to see this here. Whenever the price changes, then the quantity changes by the factor of minus 2 of that change. So that gives us the different numbers here. If it's 25, we have a demand of 50, or 52 if the price goes down even further. And if it's 20, we have a quantity demanded of 60 or 62. And in fact, we see, as we saw here in all cases, delta P is -1. We can also say that in all cases, delta Q is 2. Now, this gives us the possibility to compute the elasticities. We have the 2 deltas down there, delta P and delta Q, and we have the original values, 20, 50, and 60. These are the values that we need in order to compute our elasticities. We can now compute the elasticities for the different points using the formula that we have up here. Delta Q over Q divided by delta P over P, or the relative change in quantity, the relative or percentage change in quantity divided by the relative change in price. That's why I wrote here relative changes, and let us write down these relative changes so that we then in the next step will be able to compute the elasticities. Okay, relative change in quantity, relative change in price for each and every situation, for the three situations. And in the same way, we can compute the other two situations, situation 2 and 3. If you want, you can again pause the video and then check whether you come to the correct results. The denominators are all the same. It's always 2 over the quantity and minus 1 over the original price. The original quantity here was 50 for the second situation and the original price 25. In the third case, the original quantity was 60 and the original price was 20. We come to 4% for quantity, and we also come to 4 or minus 4, negative 4% for the price change. So here the elasticity will be minus 1. And in the last situation, 2 over 60 and minus 1 over 20 gives us 3.3% for the quantity and 5%, minus 5% for the prices. Now, the elasticity, we have the formula up there. Delta Q over Q divided by delta P over P is now easy to compute because we have it already there. Elasticity here is 10% over minus 0.25%, which is of course rubbish what I did. It's not 0.25%, but it's 2.5%, which most of you, I'm sure, already realized. And we come here to an elasticity of minus 4. Second situation, third situation, again, you can pause, compute, and then already think about, okay, what do we see? What are the different values? What are the different parts of elasticity? The elasticity doesn't have a unit. It's not a percentage or something like this. So we write minus 0.66 as a value of the elasticity. It's not 66% or something like this, but it's the relation of the two percentage changes. Okay, so what do we see here together with the definition that said, as we can see here, if elasticity is smaller than 1, skipping the sign, if the absolute value of the elasticity is smaller than 1, we call it inelastic. If it's bigger than 1, we call it elastic. So in fact, we have the three cases here. We have the unit elasticity in the middle, and then we have an elastic and an inelastic demand. This is our definition, and we will see what we can do with this definition. Basically, we will find out that for each and every situation, or for each and every demand function, we can observe these three parts of the function: the upper part elastic, the lower part inelastic. And that's something that we are going to observe for each and every linear function, for each and every demand function that is a straight line. We have the upper part elastic and we have the lower part inelastic. And in between there's only one single point, which typically is at half of the p-axis and half of the q-axis, right in the middle, where we find the situation of unit elasticity. Okay, fine. Now we defined the different values, and we have one more step to go, one more computation to make, and that is the total revenue. Because the question is now, why should there be a price strategy? Why should we say, okay, we want the firms to act in a specific way, if it's not to make money? So let's talk about the total revenue, TR, or you might as well say sales. And total revenue, again, we can briefly think, how is total revenue normally defined? The sales or the total revenue, what is it that we would write down? TR equals what? How do we compute total revenue? And the typical answer is it's price times quantity, or quantity times price, whatever. P times Q is how we normally compute the total revenue. So for all the three situations, we are again able to compute the total revenue before and after the price change and the change in total revenue. Let's do this. And you already know the game in the meantime. We can compute this. Price times quantity, so 40 times 20 gives me a total revenue of 800. And if you want, you can pause and compute on your own and then check whether you come to the same numbers. So we get changes in the first case of plus 58. The total revenue goes up. In the second case, the total revenue is more or less the same, minus 2, a small loss. And in the third case, the total revenue goes down more substantially, minus 22. So we can observe that in the situation where we increase the prices at an elastic demand, total revenue went up, whereas in the situation where we increased the price in an inelastic demand, the total revenue goes down. And in the middle, for a unit elasticity, this more or less the total revenue stayed the same. So now we did this sort of by doing in order to earn, we could say, the slide, the overview slide that gives us exact this information about the price strategy. Because what we learned is that in the upper situation that we just named, if we have an elastic demand, it makes sense to go down with the price, so to have this minus 1 in order to increase total revenue. Whereas in the case of inelastic demand, it was a mistake. So what we should have done is to increase the price in order to increase our total revenue. And this is what we see on the slide, number 18. The value, we can sort of only read this, is exactly what we learned. Elastic, inelastic, and then the price strategy if a firm wants to maximize. In case of inelastic demand, they should increase the price. And in case of elastic demand, they should decrease the price. And this is the definition we should take home with us, put it on our board so that this frame number 2 now gives us all the information about the value. First step, compute the value, look at the value and compute the value of elasticity and learn from this the price strategy. If you are a manager of the firm and you want to maximize the revenue, which is a typical target of a firm, not the only one. At the end, we're going to talk about maximizing the profit. But here, first step, if you want to maximize the revenue, then follow this rule and use the concept of elasticity in order to follow your goal as a firm, as a manager of a firm. That leads us to the third part of chapter 2 of this second video, still about elasticity. And you might recall elasticity, we said we are going to discuss number 1, the value and the price strategy. This is what we have been doing up to now. And then number 2, the sign. And from this sign, is elasticity positive or negative, we can derive the type of the good. And you see here that it's about epsilon being bigger than 0 or smaller than 0 or equal to 0 for perfectly inelastic. So no absolute bars here. That's something that from time to time confuses people, that here we have been dealing with the absolute value, bigger or smaller than 1, and now we look at the sign. So we don't use the absolute value, obviously, and we look whether it's bigger or smaller than 0. What we differentiate with the sign are 3 different types of elasticities, the one of which we have been discussing all the time, the direct price elasticity of demand, where we differentiate normal, essential, or luxury goods. We add 2 more things. We add the cross price elasticity of demand, or indirect price elasticity is another name. And here we differentiate substitutes, neutral goods, or complements. And we come to the income elasticity of demand, where we differentiate superior, essential or inferior goods. And you can see here it's just an epsilon, xy epsilon, the cross reaction between the goods x and y. And here the y stands for income. All these elasticities are defined in a similar way. It's always the percentage change in quantity demanded divided by, for income elasticity, the percentage change in income. And for this cross price elasticity that deals with two different goods, x and y, it's again the percentage change in demand of one product, product x, induced by a change in the price of another product, of the product y. The next slide, which is again a bit red, shows us what we should recall. So on the one hand, the three names, direct, indirect or cross price income elasticity. How are they defined? Delta Q over delta P over P. We know this one, and then these definitions look quite similar. Delta Q over Q for the one good divided by delta P over P from the other good. Or here delta Q over Q divided by delta Y over Y, so the change in income. We come to some examples by looking at this matrix that differentiates on the one hand the three different types that we just heard about and asks, is the sign negative, is it positive, or is it equal to zero, in order to differentiate these different types of goods. Let's have a closer look to this. So you see that we added this matrix in order to fill it, and on the other hand also the overview up here, making the difference between step 1 the value, step 2 the sign, and you can also see here in the name of our frame 3 the sign of elasticity in order to derive the types of goods. And we can do this sort of quite applied by finding examples. We might point out that basically when we look at the formula of elasticity, we see that the sign of the elasticity at the end is the same sign as the slope. It's the B that determines the sign of the elasticity, which means that when we have a negative elasticity, this is a relation between the quantity demanded and the other influencing factor, which can be the price of the good itself, the price of the other good, or the income, depending whether we are here, here, or here. That's why there is sort of nothing on the vertical axis as the vertical axis changes. Elasticity equal 0 would be a vertical line, and elasticity bigger than 0 would be a positive slope. And now we can think, what is, for example, the normal situation for the direct price elasticity of demand? And I suppose we all have this in mind and in front of our eyes. We always worked with a downward sloping demand function. So these we call normal goods. And normal goods can be food, coffee, cheese, clothing, everyday things, holidays as well. Whereas when we look at this type where the elasticity is 0 or the demand is perfectly inelastic, which means whatever the price, we pay it. We buy the goods for that price. You might think of examples, and we call those essential goods. And you might come to things like water, air, that we definitely need, energy, but also things that we need on a daily basis, toothpaste, toilet paper, drugs, in the sense of medical drugs. When we really need them, we will be willing to pay whatever it costs. The upward sloping relation between quantity demanded and price, so if the price goes up, people buy more, and the price goes down, then people buy less, is the unusual way. Are goods that are not normal, but where people act in a different way. We call those luxury goods, or sometimes snob goods, but the formal name is luxury goods. And I suppose most of us think about luxury brands like Hermes, like Rolex, Louis Vuitton, and stuff like this. It might as well be other things where people pay a lot of money, although the good is comparable to others that are available cheaper, and it often has to do with the brand, like Apple phones, computers, and so on. And of course, all these examples are exactly this, just examples. We can in class go over the matrix and find other examples or discuss whether you find these examples appropriate. Cross-price elasticity or indirect price elasticity. What is the relation between the two goods? And we already heard the name substitutes on the one hand and complements or complementary goods on the other hand. Substitutes, I can substitute one good by the other. We had this earlier, that we say if apples are too expensive, I might substitute apples by pears or by bananas, by oranges, whatever. I don't buy apples, I buy something else. I substitute them. What do you think? Is a substitute good? Does it look like this or does it look like this? Think for a second, pause for a second. And the answer is that the relation is positive. So we have an upward sloping function and we are on the right hand side. Here we talk about substitutes or substitute goods. When the price for apples goes up, then the demand for bananas goes up as well, because I buy less apples and I buy more of the other good. Apples, bananas, butter, margarine, tea, coffee, and whatever might be examples here. And the opposite are called complements or complementary goods. Things that we normally buy together, typical example, butter and bread. When we normally have bread with butter for breakfast and now the bread becomes more expensive, we might decide to eat less bread and more cereals and so on. If we eat less bread, we also buy less butter. And that makes the downward sloping shape of this relation. In both examples, so all the examples that I wrote down here are of course only examples, and we might as well discuss about this. There might be people who say tea and coffee, never, there is no, these are no substitutes, but I only take the one, or coffee and milk. There are people drinking coffee without milk, but I hope that the basic message comes through. And then in between we have what we call independent goods, which are goods that don't have to do anything with each other, like salsa and bananas, carpets and milk, cars and chocolate, and so on. We will find quite a lot of examples here. And so when we compare these two, we have on the one hand here the normal goods, which are also called normal. So this part of the matrix is the typical examples. Example, as are the independent relations. Although we often more frequently talk about complements and substitutes, but in reality, most goods are not directly connected. Bringing us to the last situation, income elasticity of demand. And here you might find out and say, okay, the normal situation that we find most of the time, what happens if my income increases? I buy more. I have the possibility to buy more, and I'm going to buy more goods and services. And in fact, as sort of the word normal is already taken, we could say income normal goods, but we normally talk about superior goods. And you see, I just copied the examples from up there, normal goods in everyday relation. Whereas the opposite situation, not normal goods, goods that are demanded less when the income goes up and more when the income goes down, are called inferior goods. That's the pair inferior, superior, superior, what we normally consider normal, And inferior goods, the opposite. Also here, you might want to think for a moment, but you basically come to that these are the very simple goods, the cheap goods, the no-name goods that we buy when we don't have a lot of money. But if our income increases, we normally change from these simple no-name goods to goods of a higher quality, to organic goods and so on. So that's what inferior goods describe. And in fact, in the middle, we have again something like essential goods. Whatever our income is, we buy them because we need them, because we have to buy them. So we can just copy from the first line. And highlighting the normal or superior goods completes our table that introduces the different terms, the different types of good that you should commemorate and know the difference between superior, complementary goods, luxury goods, and so on. How are they defined? Which type of elasticity do we use in order to define that good? And the second step is to ask, what can we do with those? From this matrix, we go ahead in our presentation and our book, part 2.6, and the following offer some business applications answering or discussing the question, so what can we do with these findings that we had here? Pricing, revenue, and elasticity, that was something we already discussed in the first part. Elasticity and the product life cycle. If we are able to find out what is the product life cycle, in which stage of the product life cycle is my good located at the moment? Am I still at the introduction, but this is most important? Are we still in a growth phase, or are we already up here reaching maturity, or are we even in decline? If we know this, then we already have an idea of the elasticity. And let's keep this as a task for the class, a task that you can think about along this product life cycle. What are the different elasticities? At which part of the product life cycle is demand elastic? At which part is it inelastic? And what does that mean based on the stuff that we have been discussing? What can we conclude? How can we use this knowledge in order to follow, again, our objectives of maximizing revenue, maximizing profit? Besides the product life cycle, an interesting application is what we call the consumer surplus. And you see here the figure 213 that you find in the presentation, and you find explanations in the book, obviously. You see here it says this is the consumer surplus. Let us have a bit of a closer look here. This is a normal downward sloping demand curve, quantity demanded. And this demand curve at the end reflects something that we call the willingness to pay of the consumers. Basically, the plans that we have in our head when we say, I want to buy something. So let's say I go downtown or online, whatever, because I need a new pair of trousers. And I have the feeling, okay, this certain quality that I want, it has to be good, it has to be light, it has to fit well. I might well have to spend €100 for this trousers. So my willingness to pay is €100, and I go downtown or online or whatever, and I find out, hey, there is exactly this trouser that I want, and I try it on, it fits, and so on, for €70. So when we look at our graph, that would look like this. Now we can imagine all the consumers that possibly buy something. Here I wrote down 1,000, but in fact at the price of 70 it might be something like 400. All these consumers, we all have a plan in our mind. We all have a willingness to pay. And let's say I'm the one with the highest willingness to pay, $100, and the next person you would be willing to pay 99, the next 98, 97, and so on. So we could say that all the consumers are sorted down here, Peter, Paul, Mary, Adrian, and so on, one person after the other. Consumers sorted by their willingness to pay. That means to me personally, I was willing to pay 100, but I only have to spend 70, which means the difference, willingness to pay minus price, 100 minus 70 is 30, is sort of a surplus that I have, is something that I spend on other goods. I could buy a shirt, I could buy a tie, I could buy 30 scoops of ice cream or whatever for these extra surplus, for these 30 bucks. The next person who was willing to pay 99 and only have to pay the 70 has a surplus of 29, and so on. As long as we are here at that point where the marginal consumer was willing to pay 70, she pays 70 and goes home and lives happily ever after. The others with a lower willingness to pay, in fact, are not going to buy because their willingness to pay is lower than the price that is on the market, that is out there on the market. That's why we call this shaded area, this triangle here, consumer surplus, which is something from our point of view that is nice. We get the goods that we want, but we don't pay as much as we would have been willing to pay. From a firm's perspective, this is not as nice because a firm would like to get the willingness to pay. So if the shopkeeper knew, or if the system online knew that Peter was willing to pay 100, they would have changed the price tags and would say, hey, here's the trouser that fits for you and it's 100 bucks. If it fits, I would have bought it and they got 100 instead of 70. So it's a sort of information problem. And it's something that if a firm wants to exploit the consumer surplus, this firm has to know basically the price, or has to charge individual prices of each and every individual consumer. And we call this price discrimination. And in fact, we differentiate different degrees, as we call it, of price discrimination. Price discrimination of first degree would be if the firm is able to charge exactly the willingness to pay, so there wouldn't be any consumer surplus left. Price discrimination of second degree typically has to do with conditions, with the quantity. So it's often if you buy more, then you get a lower price, the typical buy one, get one free, and so on. These stories or these approaches would come in here. Third degree is a type of price discrimination where the firms offer the goods in a bit different way, the basically same good that is offered in different packages, that is offered in different ways of promotion, of distribution, at different prices. There's a bit of a definition in our book, Table 2.5, that defines the different types of price discrimination. And also here you can think a bit about it, whether you find examples, and we might discuss this in class as well. Which brings us to the last application and the last argument in this chapter 2. It's about the question, okay, now we talked quite a lot about demand functions, but where do we get them from? Surely there's no direct way to find out, or there's typically not a direct way to find out. There won't be the people out there saying your demand function is exactly 437 minus 3.24 times price, but we have to estimate the function. Estimation is a mathematical term, a statistical term that you might be aware from your statistics, your quantitative methods classes. And I want all of us to have a look at this relation. Let's say you observe, either yourself, you observe your consumers, or you hire a market research company. You observe the following relations that you see here at the point where you charge the price of 4, then people bought only some 100 goods. If your price was 350, it was 2,000 or 3,500, and so on. For a price of 1, in fact, people bought something like 7,000 and some goods. This is how this diagram can be read. You see the numbers on the right-hand side. And also this we take home as a task to think about what is your demand function. So how can we estimate this? And as a hint, it's a statistical tool. It's something that you learned in statistics. If you have X, Y numbers, then you can estimate this function. And secondly, what do we learn about elasticity? What does that mean for elasticity for the different prices that you as your firm charge? Thanks for listening to our video about Chapter 2, the second video, Elasticity of Demand. I hope you got some ideas here, and I'm looking forward to discussing your questions and further applications in class with you.